Alright, in this lecture we're going to cover limits. What is a limit? A limit is the value of a function as the variable inside approaches a particular value. So why don't we take a look at an example to clarify our understanding. What is the limit of function x plus 3 as x approaches 2? Now, what that basically means is, what is this function right here equal to as x approaches 2? And this right here is limit notation. You'll usually see this question asked to you in this form on your tests and quizzes. Now, the first solution is just to simply plug in the value. That's pretty easy in this case. You just plug in 2. 2 plus 3 is 5. The second solution is to plug in numbers really close to 2 from both sides, and I'll explain what both sides means in a second. So, the first thing that we're going to do is plug in a number that's really close to 2. For example, 1.9. So 1.9 plus 3 equals 4.9. Now let's get even closer to 2. 1.99, that gives you 4.99, and so on. And then from here we can see that the function is clearly getting closer to 5. Now, if you add a number that's really close from the right side, you'll see that the value of the function also approaches 5. So in case by now you still don't understand what left and right means, left basically means that the numbers that you're plugging in are smaller than the actual number. So 1.9, 1.99, 1.999, all smaller than 2. So that's what we mean by left. And 2.1, 2.01, 2.001, they're all greater than 2. That's what we mean by right. So from both sides, the function approaches 5. And if that's true, then we can actually just say that the answer is 5. So let's look at a graphical representation of this. So if I were to ask you to find the limit of the function 1 over x squared as x approaches 0, and you graphed it, then you'd see this on your calculator. Now what this means is that from the left side, and it's a lot more intuitive when you see the actual graph, because it's to the left of 0, right? So on the left side, it's approaching infinity. On the right side, it's also approaching infinity. So because they're both approaching the same number, if you want to call it, then that means that the answer is infinity. Let's look at another example. This case is a bit different. Here we ask you, if the function is 1 over x, what is the limit as x approaches 0? So this gets a bit funky because on the left side, the graph is actually approaching negative infinity. On the right side, it's approaching positive infinity. So that's a bit odd because they're approaching two different values. And if the function is approaching two different values from the left, if it's approaching one value from the left side, one from the right, then technically there is no answer. The answer does not exist. And you can literally write D and E on your test. Does not exist. It's important to note that if x is alone on the denominator of a function, while a constant is on the top, then approaching infinity will give you a limit of 0. So basically what that means is if you have x on the bottom and just a random constant on top, whether it's 10, 8, 5, 3, and if x is approaching infinity, then this is going to equal 0. And if that's not intuitive to you, then you can just look at this, right? 10 over 2 equals 5, 10 over 100 is 0.1, 10 over a million is 0.00001. So the bigger the denominator gets, the bigger the number on the bottom gets, the smaller the whole value is. And infinity is infinitely large, so technically the limit, if x is on the bottom, so technically if infinity is on the bottom, then the value of the limit is 0 if a constant is on top. Let's take a look at another example. Now this is a bit different because we have an x on the bottom, but we also have an x on the top. So what does that mean? So basically what you want to do is you want to find the highest power in the numerator, right? The numerator. the highest power is 4x, and in the denominator, the highest power is 9x. You also want to find the highest power in the denominator. So then you want to compare the highest power in the numerator and the highest power in the denominator. And you want to divide them. So you want to just ignore everything else. So you can ignore plus 6, and you want to ignore minus 3. So all you have to do is 4x over 9x. And that gives you 4 over 9, which is your final answer. And in case you still don't understand what highest power means, it basically just means find the term that has the highest exponent. Let's take a look at another example just to clarify what we mean by highest power. So 3x squared plus 6 all over 12x squared minus 3 as x approaches infinity. Now this only applies, keep in mind that both these examples actually only apply when x equals infinity, is approaching infinity. So what you want to do is find the highest power in the numerator, which is 3x squared. The highest power in the denominator is 12x squared. And that gives you 3x squared over 12x squared, and that reduces to 1/4. That's your final answer. Now, these are a couple of rules regarding trig functions that you want to actually memorize. You want to have these memorized because you're going to need these to solve certain problems. So, if you have sine x over x and x is approaching 0, then that equals 1. So if you see this in a problem and x is approaching 0, then you can just plug in 1. Rule number 2 is cosine x minus 1 all over x equals 0. So you want to have these two definitely memorized for your test. Let's take a look at an example that requires you to use your knowledge of one of these. Sine 4x over x. So it's not exactly the same because you have a 4 here. So we're going to actually have to change it up a bit. So we're going to actually use a bit of algebra to make the problem suit our needs and fit the requirements to use that rule we just mentioned. So the first thing we're going to do is multiply the top and bottom by 4. That gives you 4 sine 4x all over 4x. Substitute a for 4x. Now you can just pull the constant out right here. You can pull that out because it's a constant. And you can substitute 4x for a. And here we can see sine a over a. And that actually fits the format of our rule from before that we're talking about. From here we can use that rule that we're talking about and just substitute this whole thing with 1. Replace it with 1 because that's what our rule says. So that gives us an answer of 4. Let's take a look at another example that requires you to use the rule. And it's much simpler after we went over example 6. Divide both the top and bottom by x, and use the logic from the previous example to get to 7 over 3. And if you see sine a constant x over x, then that equals that constant, as long as x is approaching 0. Okay, so this is just a final example regarding limits where you're just going to have to use a bit of algebra. So you can't just plug in 2, so you're going to have to go through a couple of steps to simplify this in a way that we can just plug in 2. So we can actually break this up, x squared minus 4. We can unfoil it into x plus 2 and x minus 2. Then the x minus 2 and the x minus 2 cancel out, and then you're left with x plus 2. And then from there, you can just plug in 2, right? Because there's no problem with that. You couldn't plug it in originally because then you get 0 on the bottom, and you can't divide by 0. So here you get 2 plus 2 equals 4, and that's your final answer.